Okay, we're going to take a look at finding areas between two curves. I want to find the area between these two curves right here. And we know that the integral gives us the area underneath the curve, between the curve and the x-axis. So we can use that concept here to find the area between two curves. If we think of one strip connecting those two curves, the length of that strip is the upper y value minus the lower y value, so y sub 1 minus y sub 2. But since y sub 1 is 2 minus x squared and y sub 2 is negative x, we can substitute. The width of those strips is in the x direction, so we call that dx. The area of a strip is length times width, because it's a really, really thin rectangle. So we found the length is 2 minus x squared plus x. The width is in the x direction, so that's dx. To add those up, we use the integral. These two curves intersect at negative 1 and 2, so we take the integral from negative 1 to 2. Evaluate, and we find that the total area between is 9/2. So in general, the formula is area is the integral from a to b of f sub 1 minus f sub 2 dx, where f sub 1 is the upper curve and f sub 2 is the lower curve. And it's one of those formulas that we just use so much that we don't really ever view it notationally, we just understand how to find the area between two curves, integral of top minus bottom. So we have to notice, for this example, if we're trying to find the area bounded by this region, is that y equals x minus 2 doesn't show up until x equals 2. And so the strip going down from root x to the x-axis is different from the one going down from root x to y equals x minus 2. So we'd have to split this into two separate integrals, integral from 0 to 2 of root x to find the area under that curve, plus the integral from 2 to 4 of root x minus parentheses x minus 2. We could do the same problem by switching the orientation of that horizontal strip, of that strip to make it horizontal. Now the thickness is dy, which means we need all of our equations in terms of y. So if y equals root x, that means x equals y squared. If y equals x minus 2, that means x equals y plus 2. So the integral now, since our thickness is dy, everything is in terms of y. So our limits of integration are y values. So y goes from 0 to 2. And rather than doing the integral of the top curve minus the bottom curve, it's the integral of the outer curve minus the inner curve. So that would be y plus 2 minus y squared. So it's important to understand that the limits of integration and the variable within your function always match the variable of integration. So you always identify the orientation of that slice. Is that going up and down? It would be dx, or is it going left and right? That would be dy. And that determines everything else that goes into the formula. So we take the integral and evaluate to find an area of 10/3. Strategy for finding area between two curves. Sketch the curves to see what they look like. Decide which direction your strips are going to be oriented. That will determine your variable. Write an expression for the area of one of those strips using dx if it's going up and down, or dy if it's going left and right. Find the limits of integration. If you chose dx, then those are going to be x values. Dy, those are going to be y values. And then integrate to find the total area.